Look at our moon. Dead, cold, cratered, and silent. This is what a moon should be. But there is one lava moon in our entire solar system that breaks every rule of physics. Not one of many, not one of several, just one. Welcome to Io. It is Jupiter's innermost large moon and the most violently active world we've ever observed. Io is not slowly cooling down. It is not calming down. It is not evolving towards stability. It is a world where molten rock permanently shapes the surface, where the ground itself behaves like a living fluid, and where volcanoes never truly stop. It is being kept molten on purpose, by gravity. By all laws of planetary science, Io should be frozen solid. So that immediately raises a disturbing question. If it's too small to generate its own energy, what is keeping Io on fire? And once you start asking that question, an even stranger realization appears. Io isn't just hot, it's being forced to stay hot. Something in this system is constantly pumping energy into the moon. But what could possibly supply that much power? Io is small, smaller than Earth's moon, smaller than Mars. It is far too small to still contain internal heat from its formation billions of years ago. If Io were alone, it would be a dead rock, a frozen tomb like our own moon. But Io is not alone. It orbits dangerously close to Jupiter, deep inside the strongest gravitational field in the solar system outside the sun. And Jupiter never lets Io rest. As Io moves along its orbit, Jupiter's gravity stretches it, then relaxes it, then stretches it again. But here's the strange part. Jupiter alone still shouldn't be enough to melt an entire moon. Something else is helping. And that's where a cosmic trap appears. Io's orbit is kept slightly elliptical by a precise gravitational resonance with Europa and Ganymede. For every orbit Ganymede completes, Europa completes 2 and Io completes 4. Every time Io tries to settle into a stable, peaceful orbit, the other moons yank it back out. This 1 to 2 to 4 rhythm creates a repeating, violent gravitational kick. The result? Extreme tidal heating. The solid rock beneath your feet on Io rises and falls by as much as 100 meters every single orbit. The entire moon is flexing, constantly. Io is squeezed like a planetary stress ball. Every squeeze releases energy, and on Io, that energy has nowhere to go except heat. For years, scientists debated the structure of this interior. Was it just pockets of magma? But recent magnetic field measurements from NASA's Juno spacecraft suggest an answer that is much more extreme. It may not be pockets at all. It may be a global magma ocean. Beneath the crust, a continuous layer of molten rock may be sloshing around the entire moon. No radioactive decay, no leftover formation heat. Io is being actively cooked by its own orbital motion. But if that much heat exists inside the moon, where does it all escape? The answer is written all over Io's surface. From a distance, Io looks unreal. Yellow, red, white, black. It looks less like a moon and more like a planet-sized chemical spill. But none of these colors are decorative. They are a temperature map. Io's surface is dominated by sulfur and sulfur dioxide, materials that melt, boil, freeze, and change color depending on heat. The dominant bright yellow plains, that's solid sulfur mixed with silicate rock. But look closer at the volcanic vents and you'll see dark red and orange rings. This is where the chemistry becomes strange. Normally, sulfur forms simple circular molecules, but when it is flash heated by erupting lava and then suddenly cooled, those structures break apart and rearrange into twisted chains. Those chains appear deep red. So when you see red on Io, you are not looking at static rocks. You are looking at the bloody footprint of a recent violent heating event. In other words, Io's colors are not decoration. They are evidence that the moon is constantly overheating. Then there are the white patches. You might think they are water ice, but Io is the driest world in the solar system. That white surface is actually sulfur dioxide frost. Io has a thin atmosphere made almost entirely of volcanic gas, but it is extremely unstable. Every time Io passes into Jupiter's shadow, temperatures collapse. The atmosphere literally freezes and falls to the surface like toxic snow. When the moon bursts back into sunlight, the snow instantly sublimates, turning directly back into gas and reinflates the sky. The moon is literally breathing heat into space. Finally, the black areas, the hottest spots on the moon, fresh lava lows and active lakes of molten rock. Because Io has no wind, no rain, and no oceans, there is zero erosion to wash away these scars. Every eruption is preserved perfectly until the next one covers it up. Io doesn't hide its chemistry, it puts it on full display. Yet, if you look closely, there are almost no impact craters, which raises another question. What kind of world erases its own surface faster than asteroids can hit it? The answer is simple. Io doesn't have a few volcanoes, it has hundreds. Over 400 volcanic centers have been identified, and this number keeps increasing. It pumps out 100 times more lava than all of Earth's volcanoes combined. But these aren't your typical mountains with holes at the top. On Io, volcanoes are vast, gaping depressions called patera. Some of them are enormous. Take Loki Patera, a single lava lake larger than the state of Maryland. In 2024, Juno flew by and provided our closest look yet at this terrifying feature. The lake is covered by a glassy crust of cooling lava. Periodically, this crust fractures and sinks. Juno even spotted massive islands suspended in this magma sea. This implies a catastrophic cycle where the entire lake overturns, creating massive rolling waves of fresh lava that consume everything. Meaning parts of Io's surface are not just volcanic, they're literally oceans of magma. Some eruptions are explosive. Volcanoes like Twashtar act like massive geysers, shooting material hundreds of kilometers into space, forming umbrella-shaped canopies in the low gravity. The lava flowing here reaches an astonishing 1600 degrees Celsius. This ultramafic lava, rich in magnesium, is so hot it perfectly mirrors the chaotic, violent conditions of the early Earth billions of years ago. The activity is so intense that entire regions of Io are destroyed and resurfaced in a matter of months. Mountains collapse, lava lakes drain and refill. But here's the ultimate paradox. On a moon made of sinking, melting rock, Io has some of the steepest mountains in the solar system. As the moon turns itself inside out, the crust shrinks and cracks under immense compression, forcing giant shards of rock like the jagged Steeple Mountain to pierce the sky. The surface of Io is younger than human civilization, not because it formed late, but because it's constantly destroyed and rebuilt. But wait, if Io is shooting 1 ton of volcanic material into space every single second, where does it all go? It doesn't fall back down, because Jupiter is waiting. Io doesn't just orbit Jupiter, it feeds it. The relationship between this moon and its planet is one of the most powerful electrical interactions in the cosmos. The volcanic gases escaping Io, roughly 1 ton per second, are intercepted by Jupiter's massive magnetic field. This invisible force strips the particles away, forming a glowing, deadly ring of radiation that completely wraps around the planet, the Io plasma torus. But the interaction doesn't stop there. As Jupiter rotates, its magnetic field spins rapidly, dragging this plasma with it. This turns Io into the moving part of a colossal electrical generator. The interaction creates the Io flux tube, essentially a physical wire made of plasma carrying an intense electrical current of millions of amps directly from the moon to the planet. When this massive current slams into Jupiter's poles, it triggers auroras far more powerful than anything on Earth. Look at Jupiter in ultraviolet light, and you will actually see a bright glowing spot moving through the aurora. That is Io's footprint. Io is acting like an electrical pen, scribbling on Jupiter's atmosphere with millions of volts. Io is not just volcanic, it is actively powering part of Jupiter's environment. But this connection has a deadly side. The region around Io lies deep inside Jupiter's radiation belts. Charged particles are accelerated to nearly the speed of light. A human standing on Io would receive a lethal radiation dose in minutes. Even spacecraft struggle to survive here. The Juno probe protects its electronics inside thick titanium vaults just to survive brief flybys. Io is not simply volcanic. It is trapped inside one of the most extreme environments in the solar system. And that leads to one final realization. Io should be frozen. Instead, it burns, pulled apart by gravity but never allowed to break, melting, erupting, reshaping itself endlessly. It is not evolving toward calm. It is locked into chaos. As long as Jupiter holds it in its grip, this moon will remain alive, not with biology, but with fire. A world that must destroy itself just to exist.